Are you ready to start sending navigation goals from within your Python program to your robot? Great, because this is what we are going to learn here today. This is the ROS Developers live class. Let's start. Okay, so here we are for this new live class. Today is already live class number 84 already. Wow, that's a lot of live classes. And today what we are going to do is to work on how to send navigation goals to your robot. You know how to do that already, right? By using the RBase, for example, and clicking on sending a goal. But this is not what we would like to have when we have an autonomous robot. So we want the robot to decide which goal to go and then go to that place. So we need a way to create a program that can send navigation goals to the navigation system of the robot from within the program. That means without the interaction of the user. Yes, right? So that's what we are going to learn here today. And before we start, let me tell you a couple of things. First one is that today we are going to finish a little bit earlier. So this is going to be a little bit shorter live class. But don't worry about that because so we are going to learn even a lot and do a lot of practice. And second thing is that today we are coming back to the usual format of the live class, which is about the using a ROSjet. So I'm going to share this ROSjet with you. Then this ROSjet contains the documentation for today's live class, the simulation, and today doesn't include any code. You are going to create that code with me. So how does it work? I'm going to share this ROSjet with you on the chat. So I'm going to put the link to the ROS project that we are going to use all of us together today. So you click on that link, and by clicking there, you are going to get a copy of my ROSjet. Then I'm going to show you how to open, and then you had to do all those steps with me at the same time. Once we open this ROSjet, you will have to create the code as I am explaining to you and doing also myself. Yeah? Right, so sorry, I'm explaining this to every week because I know that there is some other people here that doesn't know how it works. Then remember, the important part here is that you learned a lot. So if you have any question, any doubt, put it on the chat that is beside this video there. You can see the chat, and then I will try to keep an eye. Okay, so many things here on my desk, but I will try to answer your questions the best as possible. So don't hesitate to put your questions there. This is a free class. I mean, feel free to ask your questions. Don't feel ashamed. There is no stupid question. So that's it. Okay, so then let's start. Before starting, I would like to say hello to all the people that is there on the chat. We have about 50 people there, and we have Jay Carroll that he has just arrived. Hello. Alex, how long this class will take? It's going to take about 45 minutes. Why today we are doing this class shorter? Because after that one, we have another live class which is done by Alberto Ezquerro. It's the head of education of the construct, and he's giving, along this week, is giving a series of 2 hours live classes teaching ROS from the very, very beginning, starting with Linux. He did this live class yesterday. Today is going to teach Python for robotics, Linux for robotics, Python for robotics, and then the next 3 days he's going to use this knowledge to teach the audience about the basics of ROS. That's packages, messages, topics, and make a robot move outside of an environment. So that's why I had to finish before, because the room is going to be used by Alberto for the next live class also. Then we have Dinser. Hello, Dinser. How are you doing? Bilal, Mehdi El Masri, Hello, Mr. Arduino. Yes, hello, Mr. Arduino. I know that surname it rings some bell on me. Then Alain Gonzalez, ready, Joker, Alain, okay, Denise, he loves the pod. I imagine that you mean the podcast. Yes, the ROS Developers Podcast. I will try to publish another episode. It's already recorded, but with this thing about the coronavirus, we are overwhelmed and we cannot publish the podcast. So I will try to put one this week. Then Ramesh, Bomblek, Nathish, hello, Nahib, and Otoki. So thank you everyone here for coming. Let's go on, let's start, because otherwise I'm going to start talking and not starting. So let me share my screen with you. So now you can see here, my screen is in the ROS Development Studio, and this here is the project that I'm going to show with you. And let me see, because I cannot share. Why not? Oh, let me see. Okay, so I have a problem here because I forked. And then now I cannot share. Oh, okay. So so that's another webinar that we are having tomorrow about how to teach robotics and ROS online. So I'm going to teach to the teachers how to teach, how to do all these things. Okay, so let's finish here. And about this, oh yeah. So okay, so damn it, we have this problem here now. Okay, so how can I get this one? Is because it's a fork from another one, and the other one is from another account that doesn't exist already. So okay, so that's the first time that it's happening here, that I cannot share the project with you. Let me think. I'm thinking about how we can solve this, but it's a little bit difficult here. And let me think. Yeah, the only thing I can do, yeah, that's a mess. That is going to be a mess. Okay, so yeah, so I cannot do anything else, and I think I'm going to download this as a zip file. Okay, so now I'm going to create a new project. I'm going to live class 5084 and no robot, whatever, robot selected. Yeah, it's the ROSbot, because we are going to use the ROSbot. It's going to be public, private. Okay, yeah, then create. Okay, so I'm going to open it, and then I'm going to upload the content again. So there. I'm sorry for that. So this is my mistake, because if I go back to the project list, then I have created this project from a previous one that was private. And when you create this, it's considered a fork. So I fork the previous one that was private. Then the forks from private ones you cannot share. So that's the problem, and so stupid of me. So what I'm going to do is to do it manually. So I'm going to delete everything, upload this one here. So it's uploading. Then I'm going to uncompress, and I'm going to uncompress that one. It's a zip file, and let me see. This one, yes. So live class, and live class is unzip the ROS, this one. Okay, so here we should have the whole project right now here inside the live class. Let me check. Yeah, all the workspaces. Okay, so now I'm going to delete everything in here. All the other, the original ones created by the default empty project. So I'm going to delete all of them, and then delete them. Yes, okay. And then I'm going to move all of them here, all them to the root directory. Okay, it doesn't allow me to do that. Yeah, okay. Yes, so we have the Catkin live class is already finished. So if I delete that one, it's okay. Yes, right. So now I'm going to save it, and it is going to be ready for sharing with you. So now here is saving. Let me see if everything works. So Jupyter Notebook, let's go. It should open and show me the notebook. Okay. Not working. Let me see. ls, so notebooks, workspace, ls notebook. It's a live class, so that's correct. So I don't understand why it's not. So it's correct. Ring working directory is in this one. So let me see. Is Catkin notebook workspace? ROSbot RBS, yes, simulation. So I suppose that I can launch this simulation from DS. Here is the gazebo Star Wars maze. So I presume that is going. So please don't worry about that. So you don't have to follow all this. It's just checking that the ROSjet is correct. And this notebook, I don't know why it's not opening, but it should. Let me check it. The simulation is launching there properly. So then the notebook should also open. Okay. Yeah, there it is, the simulation. Okay, so then let's do one thing. So once this has been saved, then I'm going to share this with you. So if I go again to my list of ROSjet, I should have this one about the live class, and now I can share because it's my ROSjet. Yeah. So now I'm going to share with you the ROSjet on the chat. So this is the link, and now I'm going to the page. So there it is, the link that you have to click on to get a copy of my ROSjet. Then what I'm going to do is to launch it again. So see if everything from launching it again from 0 is going to work again. And then, so please click on there. And once you have the ROSjet, you should have, by clicking there, you should get a copy. You should get a copy on your zone of ROSjet. So you should have this one, live class 84. Sorry, it doesn't have the nice image. You can put it later by yourself. Then this one, in order to open, click on open, and then on the next window, click again open. Okay, by doing this, you are going to open this ROSjet, and you should get what I get here. And now correctly, exactly, the ROSjet, the notebook is showing properly. So we have kind of solved the problem. Okay, great, great. So let me know if that works for you, and then we are going to start with this opening. If you cannot reach this point, let me know, please. It's important because this is the basic first starting point, and I need to know that you are on this point. So afterwards, you can also come back here and check again the documentation with better detail. Then Bomblek says, that works, thanks, great. Then Hermanalan says, rule, when apology is enough. This is a live class and shit happens. You have a, sorry, I said it, sorry. You are a very good instructor, and I base this on experience as I have taught all ages for over 25 years. Okay, thank you, Hermana. Thanks a lot for your support. Thank you very much. And you are right, one apology is enough. That's right. Thank you for your lesson here. Then Far says, hello, can navigation of robot based on SLAM? Yes, so today we are going to do navigation based on SLAM. So actually on a particle filter. And then Alex is asking, will we be using kinetic or melodic? It's using kinetic, but the same things that we are doing here should work perfectly in melodic. So it's going to work. I mean, this is basic ROS navigation stack thing that doesn't change over the different distributions, almost doesn't change. Okay, so let me know if it works also for you. So I don't see any complaint on the chat. So I assume that you have reached this point here. Yes? So you have opened the ROSject, and automatically the system opens the notebook for you containing all the instructions that we are going to follow today. And then let me close this in case that you close this for whatever the reason. So if you close it, then you can reopen by going to Tools here on the menu on the top and then press Jupyter Notebook again. Then it's going to show here a list of different notebooks. Oh, in this case there is only one, so the default one is open. Okay, let me close here. That's it. So we have more space. Right. So no complaints, is still loading for Otoki. Evangelo says it's running great. So it looks like more or less everybody is getting there. Otoki 11. So I think that it's going to be no problem, of course. So let's continue. So about the subject, about navigation commands, this is not a basic live class. This requires that you know about Linux, that you know about Python, and you know about ROS basics also. And also you have to understand ROS navigation. So you have to know what it means to have a map, to launch the localization system, to launch the map server. So you have to know all this. So I suppose that you already know. In case you don't worry, then I will explain more or less with more detail, as much detail as possible, okay? But those are the very mandatory knowledge that you have to have in order to follow 100% this class. In case that you don't have, I have put there some links to our courses that you can take. Some of them, they are completely free, and they are based on practice, on the simulations, and so on. Okay, so have a look later. Then the first thing that we are going to do is to launch the simulation. So we need to have a robot that we have to send commands to it. And then for that, we are going to use the ROSbot from Usarion. As you have seen, then this layout is already like customized for Usarion's company, that because we are going to use their robot. And they send us their robot for evaluation and for doing some tests here. That's why we are doing all these live classes using their robot, because it's a very nice robot, and we find it very useful for this kind of learning specifically. So then we have another question. They're still loading for Anthony. I presume that you have already done it. Hermalan says done. Ramesh is asking which version of Ubuntu I use here. So it's Ubuntu 16. You can see the configuration we are using here on the top right corner of the window. You see, we are Ubuntu 16, ROS Kinetic, Gazebo 7. So this is the configuration we are using here. Remember that when you create another ROSjet here in the list of ROSjets, so in your list of ROSjets, you create a new ROSjet, you can select for which ROS configuration you want to create the ROSjet. Actually, we support several configurations: Ubuntu 16 with ROS Kinetic, Ubuntu 18 with ROS Melodic, Ubuntu 18 with ROS 2 Dashing, and Ubuntu 18 with ROS 2 Eloquent. So you can create ROSjet for all those, and then the system will be already working on those operating systems and ROS versions. So let's go. Tamanna says done. Great. Ramesh, okay. Then let's launch it. In order to launch this simulation, very simple. We are going to use the menu here on the top. So go to simulations. I have my simulation here still running because I launched it. But in your case, it should be this menu here. So go to menu simulations, choose launch file. And then here we have to select the launch file from the simulation files that we have in this ROSjet. So this ROSjet that I shared with you contains already the simulation of the ROSbot, and we are going to launch it. For that one, you have to go and select this one that is called Start World Maze.launch. It is inside the robot gazebo directory, the package actually. So Start World Maze, select that one, and then press launch. Then the new window of the simulation should appear here. So for those of you who are asking where are those files located in this ROSject, very simple. Let's go to Tools here on the menu of the top and open the IDE. Let's open the IDE. Is the file manager and editor for creating our programs. We are going to need it afterwards. So here you can see that we have several workspaces, and this is how we organize the packages, the ROS packages in different workspaces in order to prevent confusion when your project grows. So this is related to the simulation of ROSbot. So you can go to the simulations workspace, then source, and here ROSbot Usarion. So you can see here all the packages. You can review later all this information. This has been created by Usarion themselves. We have just cloned them, made a git clone and put them there. So we haven't done anything on that. I think that I changed one launch file for configuring for default launch of this world and so on, but not much, just a stupid configuration things. So you can have a look later, okay? That's not the purpose of today. Then we have the simulation here running. So let me know if it doesn't work for you. You don't have the simulation running, but you should get this here, which contains the ROSbot there in one given position. And then this map, this kind of environment. And when I have to tell you that when you can see this environment that is very white, everything is very white. That means that some textures have not been loaded for whatever the problem. It's a known bug in our system. If that happens, it happens randomly. If that happens and you don't want to see the environment like this, you can press this icon here that is kind of recycle icon on the top corner of the gazebo window, and then it's going to reload the vision. It's only reloading the visuals. So now you can see the difference. That is, so that allows us to see, well, actually not so much difference because that wall doesn't have any texture anyway. So just change from white to gray. That's great. From white to gray, that's great. Yes, I'm a poet, you know. Okay, so then there is a question there. Is Ubuntu 18, it's applicable? Yes, you can use Ubuntu 18. Video is not clear. Tamanna, what do you mean? ROSbot launch, how did you open the IDE? Yes, and then Francesco is saying, answering you, from tools, top left. Yes, that's it. Thank you, Francesco. And yeah, so feel free to answer the questions and help me. So we have that. Now we need to have also running the navigation system for the robot. Okay, because we want to send commands to the navigation system of this robot. Again, this navigation system is being provided already by Usarion, and it's here inside this ROSbot navigation. And then we are going just to use it as if you have already done it by yourself. So this is somewhere that we are safe, that we don't have to. In order to open the IDE, you ask, is as Francesco is mentioned, is here in tools. So the same for launching a terminal. We need a terminal in order to launch a ROS launch command. So for launching a terminal, we go to tools, and here there is shell. Beneath is IDE. So now we select shell. So now we have a terminal here, and we are going to launch the navigation system for ROSbot. And this is the one that you can see here. This command here is already done. So I didn't do that command neither. So I just took from Usarion's repo, and I just checked that it works and so on. So you can launch it safely. It's going to be running. So let's imagine that you get access to a ROSbot robot that has everything already running on top of it, but now you want to create your autonomous robot program. This is the program that is sending the goals to the robot, and that's what we are going to learn here today. So we have that running, and then let's also open the RBase. The RBase, so we can visualize in which location the robot is in its head, in the map of its head. Okay, so the robot is here in this location in the simulation. It's here, but that's what we know from the outside in the simulation. But where does the robot think that it is? Okay, so we don't know based on the map that has been created already. So I created the map already for you and provided here to the navigation system. So now this navigation system here, it's running, it's using the map that I have provided. But how can we see that map and where in that map is the robot located? For that, we need the RBase. So let's launch the RBase. We need another terminal because this one is already being used by the navigation system. So let's go to Tools again, select a new shell, and let's launch here the ROS run RBase with this specific configuration file. So this is a configuration file I have created specifically for this live class. So it's going to save us some time also. So you don't have to configure all the map, laser, and so on. So this is already configured. It's going to save us some time. Now, let me know. Then Tamana says, this video blurry, I can see clearly. Tamana, we are transmitting in high resolution. So if you are seeing that blurry, it is probably because you haven't selected the configuration in your YouTube. You can select up to 1080p. So you need to go to YouTube, to the YouTube configuration and select the quality 1080p. Then Gizem says, what did we run on the terminal? Which one of them? So we have two terminals. The first one is the one that we run, the navigation system, is this command here, ROSbot navigation AMCL demo. Then the second terminal here is the one that we launch, RBase. And RBase is the one that is going to visualize the system. If you get this message here, CPU RAM usage is too high, don't get scared. It's just showing you that you are running to the top of this free account, and you can keep doing it. You can keep, just press this. Means it's a way that if you need to move faster, you need more processing power for doing your system faster, then you need to buy some credits, and that's how we get some money in our platform. Okay. You have to check it now, and then check it now is going to let you know how to buy some credit. So I was answering about GSM that says we run in the terminal is this command here for launching RBase. But we have launched it, and where is RBase? We can see nothing. Well, this is normal because this is a web environment, and RBase is a new terminal. It's a new window, sorry, it's a Qt new window. In order to see those windows that are created by programs, we need to go to Tools and then select Graphical Tools. Then if you select Graphical Tools, then you're going to see here that it appears the RBase in there. So you can do it like that. And actually what I'm going to do, because we are starting to get too many windows here, what I'm going to do is to remove this window that I'm moving now, the one that contains RBase, and I'm going to put it as a new tab here in my browser. For that, you can do it by clicking on this icon here, the first icon on the top right corner of the window itself. So click on there, then we see that we have been teleported to this new tab. You see here is in my browser. This is the tab of the window of the RBase, and this is the other tab where I'm keeping working normally. Okay, so here we have, and we see the map, the robot, the particles, the laser. Great. Let's continue. So the first thing that you may need in a program in order to create your autonomous robot is to set the initial pose of the robot. Then in this case, it happens that it's more or less correctly set, more or less. But this is just by chance. This is because the simulation started on the same point as I started when I created the map. This is just by chance. But you cannot take that for granted. So you need to set your robot in the initial location of the map when you create an autonomous robot. So for that, let's do that. It's very, very simple. So first thing we are going to do is to create a package, a ROS package, where we are going to set all this code. So for that, we need, again, another terminal. So go to Tools again and select a new shell. Yeah, so you know that ROS requires a lot of terminals. Then you have the command here about how to do it, but basically we have to go to the Catkin workspace, where we have to do the program, the package. We have to create there the package. So in order to go to our Catkin workspace, we take the command ROScd. Then we go one directory down. And then, so we are now in Catkin workspace, but remember that the ROS packages, they have to be on the source directory. So we go inside source. Then next command is to create a package there. So let's do a Catkin create package. Then we are going to call it autonomous _ nap, and then and then we are going to provide as dependency ROSpy. So this is going to create our package. Then we have Jekhor on the chat that says he has a problem. I have a robot, ROSified, and using navigation style, my robot moves with curves. The global plan is okay, however, the local plan is very curved. This is a problem in your configuration of the parameters for the move base, for the local planner. Yeah, so yeah, something that we cannot do here. So you have to see all the parameters in that for the local planner and for the move base, and then there you have to tune it. Or also it depends on how your robot is. I presume that is a differential drive and so on. Then what else is RBs doesn't open properly for Tamana. Okay. And it doesn't open properly. So what do you mean? Do you mean that, do you get this message here on the terminal, Tamana? And then if you get this message, the only thing that you need to go is to go to Tools and then select the graphical tools. So you will see RBs there. So RBs is not going to pop up directly. Then Assis says, new question, why do we put -d when giving command? Yeah, so that -d in RBs is because we are loading by default this configuration file of RBs. And we are using this because in order to speed up. So because otherwise configuring here the laser scan, the map, the pose array, the path, all that takes a long time and is stupid work. I mean, it doesn't provide any knowledge really. So that's why we are using launch RBs but load this file. Okay, so we have our code created there, our package, sorry. Now we need to create a new file that should be called setinitpose.py. So let's go to the IDE. Let's use the IDE here and go. So I'm going to close this simulation workspace and go to the Catkin workspace. Inside the source, I have here my package, autonomous nav. You see, autonomous nav. Then there, I'm going to, here we have the source, but the source directory is empty. So what I'm going to do is select it and then do a right click and indicate new file. Then my new file is going to be called set_init_pose.py. This is the file that is going to set, that contain the code that sets the initial position of the robot. And then here is the code that we are going to put inside there. So let's do one thing. Let's copy, and then I will copy and paste, and then I'm going to explain you the code, okay? So copy this. So select everything, Control C, and then come here, Control B. So you can select the whole code of this cell, Control C to copy, and then come here to the file setinitpost.py, and then press Control B to paste everything in there. And there it goes. So what does this code does? Well, let me go to the most important part here. Basically, we are creating this node, is a new node, and then we are going to publish into a topic that is called initial pose. This topic is provided by the AMCL node. The AMCL node is the node for localization. Okay, so the localization node that we have launched here in the navigation system. So that node is the one that is providing this topic. And then we are going to publish there one specific location. So we are telling to the navigation system, hey, please understand that the initial pose of the robot is this one, this specific one. Okay, so that's the way to create a publisher. You must know this. And then the type of message that we are using there is a pose with covariance stamped. And so that's what we do. We create the publisher here for that node, then we create an empty pose with covariance stamp message, and then we fill it. What do we have to fill? First, we have to fill the frame ID. The frame ID, it means from which frame we are providing this pose. So this pose, that it means the coordinates. It means X, Y, and Z and orientation. So from which frame are those coordinates being measured? So that's from the map. Yes, so that's exactly that is. So based on the map is the 0, 0, 0 for X, Y, and and Z is not included here. It should be, well, but it doesn't matter because by default is 0 also. So let me also add it. You don't need to add it, okay? Just for consistency. Just for consistency, so it has to be, and then it's 0, 0, 0 on Z also. X, Y, and Z, position. This is for the position. Then we have to specify the orientation. And the orientation, it's specified in terms of a quaternion. So it's not just a theta value, like in navigation, robot navigation, but it has to be specified in a quaternion. That's why the orientation has four component. So this is the orientation. I have computed this orientation for you in order to indicate that the robot is looking towards that wall over there. So I have computed that before. I may show you later how did I do that. It's very simple. It's very simple. It's not so complex. So we provide the position. We want the robot to be in the initial location, and then the orientation. Then we need to sleep a little bit here in order to allow time for the publisher to be created, because otherwise this code is going to be executed very, very fast. And then when we reach the publisher, the publish command, then the publisher would be not created yet. So that's why we need this sleep here. And then the only thing that we do is to publish. We publish this post that we have indicated, and that's all. That's it. Okay, so let's go. Let's execute this one. So for that, we need to provide execution permissions to this. So as you can see, all the steps are indicated here in the notebook. And let me go to the other terminal that we already had, the third one here. And let me go inside the package. Let's go inside the package, inside our autonomous navigation, then source. If we go there, we can see here that we have our Python program. We need to provide execution permissions. That's chmod plus X. chmod space plus X. And then the name of the file we want to provide, which is set_initPost.py. Now if I do an ls, you will see that it's in green state. Before it was in white state, after the changing is green. Now we can launch it. So check it out here, how it is this configuration in RBase. This was the default one before anything. So now let's launch this one, this our code with a ROS run. So we can do a ROS run, name of the package, which is autonomous underscore nav, and then the name of our binary, which is set init post. Exactly, set init post, then send it. And then we get these messages setting initial post set. If we go to RBase, we'll see that we have this location. So the robot is looking into that direction. And yeah, so the lasers, you can see that they are wrong. And why is that? This is why, because in the meantime, there is the robot is kind of sleeping in this simulation for whatever the reason. So it has been changing while we were talking. It has been changing its initial position somehow. So now it doesn't correspond to the one that I have set in the program. Okay, so that's normal. You can do one trick. So let's do some trick, something bad. So it's to select the robot and come here to the gazebo and use the blue light to turn it as it should be. This is not fair. I mean, I'm doing tricks here. So now you click on the other view mode here. Now the robot is set up on this position, and if we go to RBase, we should see that it has changed. Oh no, yeah, no, it doesn't, because the odometry hasn't changed. Yes, that is right, exactly. Well, don't worry about that. It's going to the error is not so big, so it's going to be auto recovered as we move the robot. Okay, so another way of doing it is coming here and doing the post estimate directly. So, but yeah, that would be cheating too much. Then one question here, it's Alex says, what is the W coordinate? This is not a coordinate, this is a component of the quaternion. So in a quaternion you have 4 components, and this is one of them, the W. So don't think as a 3D dimensional. It's a mathematical artifact. And Mike says, is the Python code good for a production release, or is there another language that needs to be used? It depends on production. It depends on what you need. It depends. So of course you can release products based on Python, of course. Then usually the robots that are sold, they are running most of the code in C++, most of them, because of speed and also efficiency and so on. And they are safer also, because Python code, you are actually not so safe that some code will make it crash. Well, yes. So I don't want to get into the details for that. So we have that initial post set, and actually if we run again the code, okay, yes, if we run the code, and it has to take the current position as the 0, 1. Yes, exactly. So so you can run again the code based on the current position of the robot, and because it corresponds more or less, you can still trick it a little bit more. Yeah, like this. And then rerun again this initial pose. So now the system is going to kind of put properly in the position that it corresponds to the initial location of the robot. Okay, so we have that running. So now let's go to the navigation goal. So how can we send a navigation goal programmatically? Okay, for that we are going to create another file. So let's go to the autonomous navigation to the IDE inside the autonomous navigation package source, and then select the source and right click and create new file. Okay, then for this we are going to call this file as set_goal.py. And we are going to do the same procedure here today. It's about copying all this move base thing code that we have here in this cell that contains a whole code. And we are going to copy and paste, and then I'm going to show you, to explain you what it's about. So you can go ahead and copy the code from the very beginning and go down. Okay, so there it is, Control C, and then come here to the file on the ADE and Control V. Okay, so let me know if you are advancing, moving forward. Okay, so let me answer some questions. Then Toki says, when I run the ROS run command, nothing happens. Okay, can you show us how you calculated the W and Z of the pose orientation? Another question. Okay, and so I will show you when I finish this. Then I will show you. Okay, it's very, very simple. You will see. Actually, I haven't calculated. I have been cheating about that, but I will show you the cheating way. Instead of using the Euler to quaternion functions that they do exist. Sorry, quaternion to Euler. Yeah, Euler to quaternion. Sorry. So there are some functions provided by TF, library TF, that allow us to do that. But there is a simpler way of doing it. I'll show you. Then Toki says about the ROS run command not working. You mean about the showing this movement? So it's not working for you? Toki, please provide more details. You should have something like this in your screen, in your RBIS screen. Then Kasem says, when creating the package, I obtained bash command not found. Okay, when creating the package, wow, creating the package is very far away. And creating the package is here. So you have here the actual command. So you have to copy paste this command here, and then it's going to work for you. Okay, in case that it's very likely that you type something wrong. Okay, so check that command and let me know if that works for you. Then we have here the SetGo code, and so in this case, in order to set a goal, we need to we have to call an action server. So in the previous code set init pose, we were publishing in a topic. Okay, so that's a topic, and then we publish one initial pose that we request to the system. For the setting the goal, for setting the navigation goal, we have to call an action server. And for that, we need to create an action client. Okay, so that's what we are doing here in this code. Basically, we are creating a connection to the action server, which is here. It's called the navigation client. It's a simple action client. And then here is the name of the action client. It's called the move base, and it is provided by the node move base also. Okay, so this is the name of the action client, and then this is the name of the message, the action message that this action server is using. As you can see, it's very similar to this one. It's name of the topic and name of the message that this topic is managing. So very similar, okay? So, but now instead of publisher is a simple action client. So you got it there. Then here we wait until the connection to the action server is made. So this is checking that everything is correct, because sometimes you may try to connect, but the other program is still not ready because it's launching still or something. Then you must wait here until the connection is made. Then what we are doing is the same procedure, is creating a move base message, but it has to be called move base goal. Okay, so why this? Because the move-based action contains 3 types of messages. One is the goal, another one is the feedback, and another one is the result. And in this case, we need to select specifically the goal because it's what we are going to send to the action server. Okay, so we create this goal and then we provide the data that basically is the same data as we had in the previous case. Is the header with the frame ID. Then I have added here the time also. That would be great to add also in the other case. Not strictly necessary, but in this case it is for different things. So you need to specify the current time where you are asking this goal. Then you provide the position, the X, Y, and Z of the goal, and the orientation you want the robot to achieve once it has reached that goal. And then you do the following. So this is the goal. Yeah, remember you call the navigation client send goal. The navigation client is the one that we have created here. Remember, it's the same as the publisher. It's the same, but in this case, it's a simple action. It's the same philosophy, let's say. And then you provide the goal and then 3 different callback functions. The callback functions, they are not mandatory, so you don't have to provide them. I just put them there because they are quite interesting they are very interesting for getting information about how the goal is being executed. And then once this is sending the goal, then here you are waiting until the goal has been completed or aborted or any problem has been done. Then I'm not going to go into details of the callbacks. Very, very simple here. You can see that the callbacks have been defined here. So because of the time, I'm not going to get into there, but basically, very, very briefly, this is the callback that is activated by the action server when the goal that you have sent is starting to be processed. So it has received and says, okay, I'm going to try to do it. Then the feedback is a callback that is executed by the action server when the goal is being executed, it's been trying to execute. So it's providing us with some feedback, like the current location that the robot is. So we can know at any point in time how far we are from the goal. And then the done is a callback activated when the goal has been finished for whatever the reason. It could be reason 3, goal reach, reason 2 of 8, goal cancel, or reason 4, goal aborted. So those are 3 callbacks that you can, and they will be activated during the execution of the goal, as I mentioned. And that's all. There is no more. So let's go and let's execute it. But first, as you know, go to the shell that we were using and then provide the execution permission. So if I do an ls, you can see that the set goal is not in green. So let's do a chmod plus x set goal. And now we have the permissions to execute. Now, what we are going to do is to do a ROS run autonomous navigation and then set goal. And then by doing this, we are going to see how the robot here is starting to move towards the goal. And we can go also to RBIS and see how the path is being plotted and the particles are distributed and so on. So let me put set goal and then send it. So are you ready? Let's hope that it works. And there it goes. There it goes. And there it goes. The robot is turning back and going to another place. I don't know where it's going. Yes, I do know. Sorry. Just putting some tension in the situation, okay? Then here you can see that the robot is trying to follow this path, not very well, but then trying to reach the location. And the particles, they are kind of distributed. Too many particles for such a small environment, I think. So this navigation system still needs to be tuned also. It was not following very well also the path. And then, yeah, so now it's turning, because it has reached the location, and it's turning to get the orientation. And here we should see the message that says goal reach. And during the execution, you can see all those messages that are the feedback information that is indicating at which location the robot is. And basically, that's it. This is a working example of this, how to send navigation goals programmatically. So let me see if you have any questions there. I'm going to go to the chat in some minutes, for a couple of minutes. So please put your questions there. In the meantime, let me provide you some homework. Should you accept to complete it, of course. Then I propose you 2 modifications to this goal. The first one is to modify the SetGo program to accept the goal coordinates as a parameter. So now the goal, it's a fixed location that I have decided to use, but you can use it as a parameter. So you can provide this when we do the ROS run, then we can provide the location as a coordinate system. Then modify this script in order to accept parameters. And then the second one is modify again this. So instead of providing the parameters as X, Y, and Z, you provide a parameter that says the name of the location. For example, the corner number 3, or the exit, or the table for customers, I don't know. Then inside this program, you have to translate that name into a set of fixed coordinates that represent those locations in the map. So that's getting you closer to a really autonomous robot. Okay, so that's all for today, but I'm going to go to the questions. And before that, please, if you like this video, help us and support us. So how can you support us? For example, by subscribing to our online academy that you have here. We have many courses for different subjects in deep for ROS, for learning ROS. So have a look here, you have the link. And also you can support us by buying one ROS developers t-shirt or one of the mugs, like the one that I have here on my table. They are super cool, these mugs, and also show that we are ROS developers. Also, if you want, if you cannot buy anything or subscribe or so, then by giving us a like and subscribing to the channel, that would be also great. That would be great for us. I will show your support to us. And that's it. So let me go to the questions here. And well, let me drink some of the coffee. It's already cold. It happens to me. I think I speak too much. Okay, so here, let me see. Many questions here. Engineering Nation says, thank you, but sorry, do you know where I can find the link? The link of what? Sorry, I missed that one. Then we have, let me go up. Oh, okay, so. Then Otoki still has the same problem with the RBIS. That's strange. I don't know. It says that maybe the internet is very slow. I don't think so. Then okay, Alex is indicating you don't have to put the dollar in your command. Yeah, that's right. Very good point, Alex. Charters, very good. It is, okay, thanks, additional dollar. Then Engineering Nation is starting in 9 minutes at the link. Okay. Engineering Nation, it is starting. What are you talking about? Oh yeah, the basic learning day 2. Yes, so it's going to start in a minute. So I have to leave because I have to leave this space for Alberto. Then yeah, so we are going to start the day 2 about Python in a minute. So please stay with us. Then the Marcus Bucol. Marcus, hello, always here. Very good, very nice to have you here, as always. The courses are amazing. I'm going to extend subscription. Thanks. Okay, thank you for your support, Marcus. Thank you very much. And then Engineering Nation is saying basic ROS learning week, day 2. He wants to start. Then I have to go. Then I'm going to do one thing. I'm going to create a new video showing you how to get the quaternion data for your goals and post it in our YouTube channel. It's a 5 minutes, 2 minutes video. It's going to be later. But now I have to leave. So thank you very much, guys, for being here. Next week, we have another live class also about ROS messages. I hope that you are there. Thank you very much and see you next week.